I don't think we can talk about roof inspections without talking about roof access and roof safety. Now, the ComSop specifically says we do not have to walk sloped roofs or get on any roofs that do not have access, or specifically any roof greater than 16 feet above the ground that does not have access. In this particular building, we have a built-in roof access ladder that's right here on the inside of the building. Sometimes they're located on the exterior of the building. So it's very important that you identify that even before you've even looked at the job or solicited the job or bid the job or proposed the job. You need to know how you're going to do the roof. And so with that, I want to talk a little bit about roof safety. Your sole most important thing you have every day is to make it home safely every night. And to do that, you have to think in a safety and safe-like manner. Not safety first, not safety second. Mike Rowe says safety third, which means safety third. Safety should be in everything you do throughout the entire inspection. Every step you take, every ladder move you make, you need to think about safety. So, most of us work alone. Most of us do not have assistance with us. Most of us go out to the job site completely alone. Well, what if there's an accident? What if something happens? You need to have a safety plan, especially for a roof. So when I have a roof access like this, and I work alone, I immediately have to, before I climb this roof, use the most important tool that I have, and that's right here. The phone is my most important safety tool. This is in my hand, this is right here. And so what I do before I climb this ladder is I'm gonna text my safety. Now my personal safety is my wife. So I will text her and I'm going climbing ladder. And so I text her and she knows to be ready. And so when I climb this ladder could be like this one, which is 12 feet. It could be 16 foot. It could be 40 feet. I climb ladders this high. If I climb a 40-foot ladder, a lot of times I'll harness up and do clips so that if I fall, I'm safe. On a 12-foot ladder like this, I'm not going to clip up. I could, but in this particular case, I'm very comfortable and I'm not going to clip up in this case. But I will text her and say, climbing ladder. When I get to the top of the roof, I'm going to say off ladder. And then I go do my roof inspection. And then I will text her climbing ladder. And then I will text her again off ladder. Now, she knows that I'm at this property. And she'll know if I don't text her in, let's say 20 minutes or 30 minutes, I'll text her again, because maybe I go up there and there's 4 or 5 furnaces up there. Maybe there's a bunch of other things. Maybe the roof is just so grand and so huge, I might be up there for 3 or 4 hours. Well, then I will let her know throughout that process that I'm safe. But she knows that if I don't text her in all those increments, she texts me. If I don't answer, she's calling 911 with this address. The other thing to consider is some of these new watches that are out there. If you've got one of these smart watches, this particular smartwatch has a fall sensor. So it knows if I have a hard impact, if I fall down, it will call 911 and send this immediately. I have dropped my watch before and it has begun the dial, and there's a code I have to put in saying, no, I haven't fallen. But think about safety. Safety, safety, safety. Okay, so now, yeah. All right, so to do the roof inspection, we need to access the roof. To access this particular roof, I've got this built-in ladder. And so on the built-in ladder, I want to make sure I can get up there. The one real key aspect of the built-in ladder before you climb all the way up there is make sure it's unlocked. A lot of these roof accesses, they will have a padlock on it. So if you take and shine a light up there, look to see if if it's unlocked. If it's unlocked, away you go. So let's go up on the roof. Make sure you always hold the ladder with at least 3 points of contact, as you move. You never want to let go with more than one contact at a time or you'll fall down. When you get up on the roof, you want to open up the hatch. Make sure you have a good safety point. This is an excellent ladder way where it's got this guardrail I can hold on to. Not all ladder wells have these excellent guardrails. And when you get up on the roof, you want to make sure you take your breath and shut the stuff off behind you. And then you go on with your roof inspection. According to the ComSop, the inspection of a roof should include, through access, all the roofs and talk about them in their materials. First material I want to talk about is the metal roof. And so on a metal roof, we've got a corrugated roof. When you see this, they're put in panels. I've got a panel here that extends to here. And so this panel is laid over the top of the next panel, which is laid over the top of the next panel, and then that allows that seam to be covered. With the metal roof, we've got the same type of fasteners that you would have on a metal siding. These fasteners, again, are tappers, self-tappers with a gasket. This is our failure point, where that gasket fails. And so a lot of metal roofs, while they might have a 50 or 75-year life, there's a lot of them you'll find they might even have a 50-year warranty. They're warrantying this and not necessarily the fastener. So just know that fasteners, being the failure point, could be the weakest spot, and that's the spots you want to look at. Now, there's no expectation you're going to walk this. What type of roof is this? It's a sloped roof. And according to the ComSop, we do not walk sloped roofs. And so that's good. And plus, on a metal roof, not all metal roofs are placed on a solid substrate. Some metal roofs are placed on structural elements and purlins. And so in that case, I might have a bank of fasteners, then 4 foot to the purlin, then another bank of fasteners, then 4 foot to another purlin. And so when you walk between the purlins, that steel can have a lot of flex. And that could be a little unnervy under feet. And so a lot of inspectors won't walk a steel roof for that reason, plus they're slippery. And so we want to watch for that. Now on this particular roof and all steel roofs, when you think of ice on them and snow on them, as the sun hits, it tends to want to melt quickly. And so as it melts, we want to catch that. And we do that through these ice dogs or ice connectors. And so what that does is as the sheet of ice and snow hits, it holds it in place. And when we have those, then that prevents large sheets of snow and ice from cascading off the roof and maybe falling onto a pedestrian or the sidewalk. And then after that, we want to make sure it looks in good shape and it's solid. But again, walking a steel roof is not mandatory. It's not part of the ComSop. In fact, it actually says in the ComSop we don't walk sloped roofs. So just do a thorough inspection to the best of your ability on what you can see, whether it's in hand here or whether or not it's through binoculars or some other means. A flat roof by definition is any roof surface or slope that's less than 3 in 12. No flat roofs are ever flat. All flat roofs have some form of drainage and drainage plan. This roof, albeit in definition is flat or low slope, has some slope. This particular roof is crested in the middle and slopes to the outside walls, and so in doing that they've created their drainage. Now it's very important when you look at all the slopes is whenever we start putting elements in, we can start messing with where the slope is. So in this particular case, I've got this bump up here. This bump up is the elevator shaft. In creating this elevator shaft, I've almost created a little drainage situation that happens over here where we've actually added a small saddle or drainage in the slope to bring that water inward to get to the drain. According to the ComSop, we're supposed to look for ponding. Now, ponding has it can be a very distinct or personal definition. One of the things I want to talk about by ponding is if I have standing water on this roof that is 20 feet by 20 feet by 1 inch, that is 2,000 pounds of water. So 2,000 pounds of dead weight on this roof sitting there, not controlled. And so it's very important to note for that ponding. Now, one of the interesting things we have as we look at flat roofs is you kind of got to have a little sense of perspective, because the last thing you want to do is start saying something is something when maybe it's not. What I mean by that is last night and this morning we've had a tremendous amount of rain. Tremendous amount of rain. And if you look at the grand scope of this roof, I would call it dry. But we have a small area here of moisture. Now that small area there of moisture is where the downspout from the upper roof is draining onto the lower roof, and as it does that, it just doesn't hit that perfectly. Now, if it hasn't rained in 3 weeks and that water is still there, I'll call that a problem. If it hasn't rained in 48 hours and that water is still there, I'll call that a problem. But if it rained this morning and that small amount of water is there, I don't necessarily call that an issue. And so it's something you got to put ponding into perspective as we go through that. The next thing we want to do after we've identified ponding is to actually identify your membrane. Of all the different types of roofs out there, this particular roof that we have on this building is an Epdm roof. This is almost equivalent to a rubber bike tire. So you can always tell Epdm because if you come over and provide a small scratch to it, you'll actually see the lines created from your fingernail. That's a very quintessential element to rubbing on rubber. And with a roof like this, it could be ballasted or unballasted. A ballasted roof would have river rock across all of this roof. An unballasted roof is what we have here, which is just the membrane. The membranes are typically adhered. So if you look through this membrane, you'll actually see all the small round holes. Those are the fasteners that are reflecting up from the decking below and the sealants. And so that's a good adhesion point. And so as you do an inspection of the membrane and of the roof, you need to really be conscious on making sure you see the whole roof. I know it's scary. We're high off the ground. Your safety is the most important thing. And so you want to be able to walk this roof in a manner for which you can see the entire roof. So that's watching the seams, that's watching the connections, and that's watching how it is. And so I want to walk this roof in a manner for which I can see the seams and I can see the connections. And so I will do that through the whole roof. And so I would want to walk this roof. And I'm looking for open seams, I'm looking for damage, and I'm looking for other conditions. What are the things that you want to actually be watching for, which is a great deal of benefit and a great deal of fun, is sometimes you'll get lucky and actually have the manufacturer's lot number and date on it. That's fantastic. If you could get a picture of that for your client, that's great for their warranty, that's great for a lot of different purposes. And so you really want to be conscious of seeing if you see that. You don't always get lucky, but some days you will get lucky to have that visible. But again, you want to walk the entire roof and not just sections of it. As you walk the roof, one of the things that's very important to be paying attention to is exposed membrane. Part of the ComSop we should be noting if we see any. What that would be is if this layer of surface that we have is damaged and we're seeing what the membrane is below it. In this particular case with an Epdm, we might not have exposed membrane because there is no membrane, this is it. And what's below us would be the foam layer. But in some buildings with a built-up roof or a modified bitumen roof, we might have a different type of material. And so it's very important that we be conscious and monitor for any exposed membranes. When you're walking the roof, it's really important to look at the whole thing. You know, don't just stop at the access point and go, looks great, because as you walk the roof, it will show us everything. When this roof was installed and we have these wonderful installed seams and that solvent welding or that adhesive that they've placed in the Epdm to fasten it to piece and make that weld is perfect. And we've walked this roof, but then we come over here. One of the things that's very important to understand is when somebody adds roof sealant to a roof, it's not because, oh, that'd be a keen idea, let's do that. It's because it's a repair. No roofer is going to come in here on the installation of this roof, come in and use A, a different color of roof sealant, and B, roof sealant. They're going to use the same material that they use through the rest of the construction. So when I come in here and I see this sealant here on the corner, and I see the sealant on these seams, those would make me keen to understand that we probably had a leak that we had to repair. So on my roof inspection of going in here and dealing with the membrane and dealing with the roof surface, this would absolutely be an item that I would want to highlight to my clients. Even if the rest of this roof, which I will say looks pretty good, this is a spot here that I need to highlight to my clients. Not saying that it's leaking today, but there's absolutely been repairs to this membrane. Within the roof, standards of practice, we are to inspect flashing. Flashing is that sealant point between objects or between horizontal and vertical surfaces. It's a diversion of water. It's to make something watertight. And so we'll have flashing points around vents where we've got this piece of mechanical vent coming up. We'll have flashing points like around the elevator shaft. We'll have flashing points where a wall comes up. Each one of those flashing points is a potential for water leakage. It's impossible to build this roof with perfectly square corners without having a potential of leakage. And so in these particular details, as they build this, the roof comes up, then we add a layer of material up, and then where that seam is, then we've cut this other material on. What's wonderful with Epdm, it's got a little bit of elastometric to it where I can stretch it, bend it over, and make that sealant. And so it really becomes a well-sealed object. And then we wanna look over at some other products where we have this heating unit here is sitting up on wood, and so we have to have a cushion underneath it. That would be a flashing point. Because that doesn't protrude through the roof, all we want to do is have that cushion. And so we've done that. Where we have a vent stack coming up, we've added the boot. We've obviously had an issue at some point because it's a different material here. And then where this boot comes up, all we have to do is put a band on it. That banding is going to keep the water from cascading down. And then they've added some mastic and adhesive around it to keep water coming down. Those are what we want to watch for with flashing points. All of our HVAC units will have it. Our roof scuttle will have it, as well as our wall penetrations will have it. It's important as you're inspecting the flashing that you don't want to stand directly up against that point. Sometimes that membrane is stretched, but it's not fully adhered. And so if you were to step right at that tangent point between the wall and the roof deck, we could stretch the roof and you could cause a penetration. Especially in a roof like this where we're dealing with an angle versus sometimes we'll have what they call a cant strip, a C-A-N-T strip, which should be making that 45-degree fillet around the edge. And then that keeps the membrane always angled up just right. So you just want to watch, and you want to watch all the flashing points as we walk around the building. Within flashing, we're going to have all of our mechanicals. They're going to have some form of penetration as they go through the roof. In this particular case, I've got an electric penetration here. This is also for the line sets for this mini split. And as that comes through here, we've got this whole assembly. These are usually never very attractive, but you just want to make sure that that you can take some form of semblance of, is it new or is it old? Again, with this multicolor on here, I can see at least 3 different times they've addressed this flashing. I've got clear, I've got this gray, and then I have the original black. And so that tells us they've had to chase something that's happened here previously. As we continue through flashing, every one of these seams is a potential for a leak. And this is what we need to be very mindful of and look at. And so each one of these seams where we rolled up and we have these adhesion points is a spot. And so as we look here in this corner, at this leading edge corner here, you'll actually see where it's opened up. And where it's opened up is a spot which could have a water penetration spot. That would definitely be a spot here on my report that I would definitely want to look for, definitely want to highlight, and make sure my clients knew that in addition to everything else we've seen, that's a spot there that needs or would benefit with some more immediate attention than others. All flashing points are spots that we need to look for. So again, watching for the seams, watching for if they're metal rust. We don't have any metal flashing on this building, so we don't really have anything to comment on or to show on that, but we want to watch for the seams, the rollovers, and watch to make sure it's adhered really, really well. Not like the spot we have right here. By definition, a parapet is any vertical penetration or wall that extends up above a roof surface. If you think of the Wild West and you got that sloped roof, and in the front of it, it said saloon, on the big flat wall, that's considered to be a parapet. On a castle, that top penetration on the top of a castle where you'd sit up there and you'd hide from your enemies and stuff like that, that's a parapet. On this building, I've got my flat surface, and then this small wall that extends up above that surface is called a parapet. Parapets should be plumb. They should be straight up and down. They should extend the roof or the wall section up. On top of a parapet is coping. That coping is the cap of the parapet. That coping could be metal rolled over like we have here. It could be stone. It could be clay. It could be concrete. But that coping is what seals the top of it on top of the parapet. In metal, as we have on this one, we've got seams at each of the coping points. Those seams overlap. Now, one of the things that I'm very keen to look for as I look across the coping on this is, you see the fasteners on this coping are through the side, not the top. By having it through the side, I don't worry about standing water on top of the coping coming in, and it's well sealed. If I came up to this coping and I see it where there's screws here, then that would give me an indication that this was raising up. If I see a whole bunch of caulk that's been added topically, that tells us we've got leakage. And when you put this on, typically you'll run a bead of sealant back here, and so when it seals down, it makes this beautiful finish across the front of it, but you typically won't have it where it's all oozed out and leaking. What else you want to see on coping is you want to make sure that it's attached. Sometimes you'll see wind-driven problems blow it up off the roof. And so you want to watch your coping. When you come to a corner where you got to create that miter joint like we've had to create there, on this particular miter joint, we do have a topical screw. That topical screw should be sealed. And so we do have a self-sealing grommeted seal on that on that mitered corner, and then we have a little bit of sealant coming up the edge. When walls fail, they typically fail at these junction points. Most of the time, we're not going to have a roof problem in the middle of the plane of a roof. If we have a problem with the middle of the plane of a roof, it's usually from an impact damage. It's usually from some form of mechanical damage to the surface. Where they're going to fail are the perimeter edges and those flash points. So where we're going up with the parapet, that's what we want to keep well sealed. So in this particular case, if you can really see tightly how they put this Epdm roof on, they placed it up, a little bit up the parapet wall, then they added another piece, rolled it over the top of the coping and down. So we've created this beautiful sandwiched layer of roof material that's going to prevent this force leakage that's happening this way. So it's very important as you do the inspection of this roof or any roof you go on that you walk your entire parapet and make sure it's all in good shape. So in the complexity of this building, we've changed siding materials. So in this section that comes to here, we've got steel siding. And in the section that extends back this way, we've got masonry siding. We have to make sure, and then as we go across the front, we have eave siding, but we have to make sure that the coping is bigger and wider to handle the entire width of that wall. In this particular case, this is what we've had to create, but in creating that, we've created a spot here that's got a potential leak spot. Driving rain, anything can happen, and so in this particular case, somebody's had a problem and they've come in here and added some extra sealant. And so that would be something that I would want to describe on my report. Even if it was something as simple as extra sealant's been added to the coping, keep well sealed. If you wanted to write a report that way, or if you just want to say prior repairs found on the coping. But definitely want to highlight this area to my clients. Inspecting the roof also includes the drainage. Drainage can be in 3 different methods: gutter, internal built-in drains, or scuppers, or combinations of any of those. So I guess there'd be 4, but there's 3 basic types. Again, gutter, scupper, and interior drain. In this building, we've got gutters. The gutters are placed over here on the metal roof. They're evacuating through downspouts, and the downspouts evacuate onto the roof surface. And so in looking at a gutter, it's very important that you look at the seams to make sure the gutter seams are in good shape, the corners to make sure the gutters corners are well sealed. And so this is what we're going to be looking for. In some cases, you can get up as high as looking in the gutter. In some cases, you can't. You're going to do this from the ground. But you'll watch the seams. You'll look at the downspouts. Most common issues we're going to find are clogged gutters, leaky seams, leaky corners, and missing downspouts. Beyond the downspout, it's very important to note where the downspout discharges to. If the downspout discharges to the ground, is it against the foundation where it's going to cause erosion, or is it going to a catch basin? Where's the downspout going? Because that's part of that topography. In this case, it's coming onto this flat roof surface. This flat roof surface, which we know is not flat, it does have some slope to it, goes into a series of roof drains. These built-in drains are across the entire perimeter of this building. So where this slope has some slope going to the outside walls, these drains are there to capture that moisture. And so the water comes off of the slope roof onto the flat roof into that drain. As the water drains this way, it goes into these roof drains. When looking at roof drains, first and foremost, are they clogged with debris? First and foremost. So if I had a whole bunch of foliage up against this building and a bunch of deciduous trees that drop leaves all year round, and they're up here dropping leaves on this building, this roof will require periodic maintenance to get the leaves and the debris off. There are no trees in direct confluence of this building. Our nearest tree is 500 yards away. So I don't think we're going to have a leaf problem on this building. But that's first and foremost what you got to look at. And then if you're looking at the drains, we have screening on each of these drains. Small little colander type screen on top of each one. That's meant to catch the debris, to keep the debris from falling down into the main drain and then causing a problem with the main line. So that's what we want to watch for. In this particular instance, where I've got a drain that has this large pond of water around it, is probably a situation where the foam layer that's beneath the EPDM isn't sculpted perfectly. And that's catching this water and not allowing it to drain. EPDM is extremely slippery when it's wet. And so I don't encourage, recommend, or suggest that you ever walk in a puddle because of safety. But you do want to look at this. If you look at this drain very carefully, I'm looking at it, I'm looking down inside, it's just dripping. So there's a little bit of debris scum directly around it. And that debris scum could be removed with a simple broom. And I bet you this would dewater pretty quickly. So it's not really a major concern, but it'd certainly be a recommendation to watch that. So you want to look at all the drains. Our most common issues that we're going to find are missing covers, missing screens. Very common. Ponding in front of the drain. Very common. And then lastly, if it was clogged and leaking. Sometimes the only way you're going to know if it's clogged or leaking is to actually look from the interior up at some of the connections. But other than that, we want to make sure that this roof dewaters. This is not a water holding ponding roof. While inspecting the plumbing systems, particularly the gas system on the roof, it's very important to trace all of the gas pipe. And so in this particular building, our gas pipe enters from the exterior on this side of the building, and then it migrates across the roof. One of the standards we need to be conscious of is that gas pipe should be coated. Should be coated. Specifically, if it's gas pipe, it should be coated yellow. We look at this roof, this is fantastic. I rarely see it so well and clearly delineated as this beautiful yellow coated gas pipe. Most of the time when we see our gas pipe, it's going to be black iron and rusting. And you're going to be making the comment almost to the point on every inspection going, recommend coating gas pipes. But in that case, in this particular installation, I'm not going to be noting that. The other thing we need to note for is that gas pipe cannot be laying directly on the roof. Laying directly on the roof will abrase and damage the roof. And so we place it up on chairs. That's what these 4x4s are chairs, and they're holding up the gas pipe.